This section examines camshafts and drives. The position of the camshaft depends on the design of the engine. It can be in the engine block, close to the crankshaft. This is called a pushrod or overhead valve system. Or there can be one or two camshafts mounted in the cylinder head. But in both designs it does much the same job, driving the valves and the distributor, and sometimes the fuel pump and the oil pump. The camshaft is made of hardenable iron alloy or steel, and it can be cast or machined. The cam lobes are ground to the proper shape and position in relation to one another. Accuracy is crucial. If the cam is not exactly the required shape, or if it becomes worn, there can be impacts, fast valve wear, or noisy operation. The bearing surfaces on the camshaft are ground smooth, and the distributor drive gear is machined into the shaft. The cam lobes are then flame or induction hardened. The camshaft has a cam for each valve. In some cases there is an additional cam known as an eccentric to operate the fuel pump. A gear on the camshaft drives the ignition distributor and often an oil pump. In modern engines, the pushrod system is being replaced by the simpler overhead camshaft arrangement. The overhead camshaft is located in the cylinder head. There can be one or two camshafts. Let's look at a single overhead camshaft arrangement. Single overhead camshafts can use rocker arms. The cam can lift one end of the rocker arm, or it can press down on the rocker arm. On double overhead camshaft systems, the most common arrangement is to use a bucket tappet or lifter. It operates in a guide that protects the valve against side thrusts, which it would receive if the cam operated directly against the valve. The adjustment of valve clearance is usually done by changing accurately machined spacers. Spacers are available in a range of thicknesses, and they're exchanged to obtain the correct clearance. Some overhead cam engines use a hydraulic lash adjuster to reduce lash in the valve train. They have zero clearance at the valve stem, so there's no need for tappet adjustment. It can be put in the valve end of the rocker arm. Like the hydraulic valve lifter, it has a body with plunger held against the valve stem by a spring. Oil supplied to the adjuster keeps the plunger in contact with the valve and eliminates lash. Lash adjusters can be put in the cylinder head at the end of the rocker arm. The lash adjusters are stationary and have a pivot for the end of the rocker arm. The plunger in the adjuster holds the rocker up against the cam. In the lash adjuster inside the bucket tappet, the plunger's hydraulic action holds the bucket body against the cam on the camshaft, and also against the tip of the valve stem, so that there is zero clearance.